Welcome to this video which is about combinations. Now let's see the content of this video. Number 1. Derivation of formula of combination from permutation formula. Number 2. How to find the combination value in easiest way. Number 3. Complementary and conditional combination. And number 4. Use of the basic formula of combination to solve some problems. Now let's start the main discussion with the question: how many two-digit arrangement can be made with digit 1, 2 and 3? Let's start the arrangement. That is, the arrangement is 1, 2, 2, 1, 1, 3, 3, 1, 2, 3 and 3, 2. Here we just arrange two digit from this three digit 1, 2 and 3. So the result is 6. When we find the arrangement or permutation, first we select the required object. Here we select two digit. Here 1, 2, 1, 3, 2, 3. Then arrange the selecting digit, that is 2, 1, 3, 1 and 3, 2. So we can say this 1, 2 and 2, 1 is the arrangement of two digit 1 and 2. This 1, 3 and 3, 1 is the arrangement of two digit 1 and 3. And this 2, 3 and 3, 2 is the arrangement of two digit 2 and 3. Now, if I ask again another question, that is, how many ways two digit can be selected from 1, 2 and 3? Now, we can easily say the answer is 3. How the answer is 3? Let's see. Within this 6 arrangement, for 1, 2 and 2, 1, we just select two digit 1 and 2. And for 1, 3 and 3, 1, we just select the digit 1 and 3. And for 2, 3 and 3, 2, we just select the digit 2 and 3. So we can say this is grouped as a one selection. 1, 2 and 3. So 3 selection. That's why the result is 3. So we can say that for any arrangement or permutation, first we select the object, then we arrange the selecting objects. Now we can write, that is, two digit can be selected from the digit 1, 2 and 3 in 3 ways. Two digit can be arranged in 2 factorial or 2 ways. That's why two digit arrangement can be made with digit 1, 2 and 3 is 3 into 2. Here first we have to select and then we have to arrange the selecting object. That's why according to the AND rules, the number of way of selection multiplying with the arrangement, that is 3 into 2, which is equal to 6. Now we can write C and R into R factorial equal to P and R. Here this C and R is for selection and this R factorial is the arrangement of selecting object, and this P and R, that is the total required arrangement. Or we can say here C and R represent combination which is way of selection, and this R factorial is the arrangement of R things, and this P and R is the number of total arrangement or permutation. So the value of C and R, that is the value of combination, equal to value of permutation divided by R factorial. We know the value of permutation, that is P and R. If we substitute the value of P and R, we will get the value of C and R. That is, we know the value of P and R equal to n factorial divided by n minus R factorial. So after substituting the value, we get the required value for the combination, that is n factorial divided by R factorial multiplying with n minus R factorial. Now we get the basic formula for combinations. To find the number of combination of n different things, take an r at a time, where n r belongs to natural number and n is always greater than or equal to r. That is C and r, which is equal to n factorial divided by r factorial multiplying with n minus r factorial. These two are the condition. N r always belongs to natural number and n always greater than or equal to r. This is the basic formula of combination which we derive from the formula of permutation. Now let's see one example of C and R equal to n factorial divided by r factorial multiplying with n minus r factorial. This formula, that is, how many ways two digits can be selected from 1, 2, 3, 4. So we have this 4 digit, that is, this one is the value of n, and we have to select 2 digit, which is the value of r. So here the value of n is 4 and value of r is 2. So the result is C4, 2. That is, if we substitute the value of n and r in the formula, that is, the value of n is equal to 4. In place of n we write 4 and in place of r we write 2. So C4, 2, which is equal to 4 factorial divided by 2 factorial multiplying with 4 minus 2 factorial, just substituting the value of n and r in the right side of this formula. Now, for 4 factorial, we can write 4 into 3 into 2 into 1. For 2 factorial, we can write 2 into 1. And for 4 minus 2, that is again 2 factorial, which is 2 into 1. After simplification, we get the value, that is 6. So the value of C42, which is equal to 6. So we can say there are 6 ways to select 2 digits from this 4 digit. Now, how to find the combination value in easiest way? Here we see the easiest way to find the value of combination, that is C42, which is equal to 4 factorial divided by 2 factorial into 4 minus 2 factorial, and the final value is 6. The value of n is 4 and the value of r is 2. That is, we find the number of way of selection of 2 from 4. If we directly write this C42 in this way and avoiding this middle 2 steps, that will be time saving and that will be easier. So how can we write this C42 as this value? First, we write the multiplication form of factorial of r. In this case, 2. So factorial form of 2 is 1 into 2. We write this factorial form of r as denominator. Then in numerator, we will write the multiplication form of factorial of n. In this case, the multiplication form of factorial 4 in descending order, and equal number multiplying in denominator. To write the 2 factorial, we need 1 into 2. And so in numerator, we will write the factorial of 4 in descending order, that is 4 into 3. That will be the required result 6. Now let's try it for this value, that is C53. In this case, we find the way of selection of 3 from 5 different things. So according to the rules, first we write the multiplication form of factorial of r. In this case, the value of r is 3. So we will write 1 into 2 into 3, which is multiplication form of factorial 3. Now in numerator, we have to write equal number of 5 factorial in descending order, that is 5 into 4 into 3. Since in denominator there are 3 numbers, so in numerator we have to write 3 numbers. So 5 into 4 into 3, which gives the required value, that is 10. In this way, we can find the value of combination in easiest way. Now, one interesting fact about combination formula, that is C52, which is equal to 5 into 4 divided by 1 into 2, which is equal to 10. Again, C53, 5 into 4 into 3 divided by 1 into 2 into 3, which is equal to again 10. Just look carefully. The value of C52 and value of C53 is equal. Both are 10. When these two values will be equal, CNR and CN n minus r are equal. If the value of n is 5 and the value of r is 2, then C52 and C5 and 5 minus 2, that is 3, will be equal. This one is called the formula for complementary combination. That is, C and R and C and N minus R are always equal. So we can say the number of combination of n different things taken R things at a time is equal to the number of combination of n different things taking n minus R thing at a time. We know the value of C and R equal to n factorial divided by R factorial multiplying with n minus R factorial. Now, if we find the value of C n n minus R, then the value will be n factorial divided by n minus R factorial multiplying with n minus R factorial, which is equal to n factorial divided by n minus R factorial multiplying with this R factorial, which is exactly equal to the value of C and R. So we can say this C and R and C and n minus R, these two are equal, which is called complementary combination. Another interesting fact about combination formula, that is C52 is equal to 10, C53 equal to 10. C52 and C53 are equal, then either these two and these three, that is the R for the first case and the R for the second case, either these two will be equal or the sum of these two will be equal to n. That is, if Cnx and Cny are equal, then either x equal to y or x plus y equal to n. So here the value of n is equal to 5 and value of x equal to 2. For the second case, the value of n equal to 5 and value of y equal to 3. Here we see these 2 and these 3 are not equal. That's why 2 plus 3 will be 5. So in this case, two things can happen. If Cnx and Cny are equal, that is the value of Cnx and the value of Cny are equal, then either x equal to y or x plus y equal to n. Now let's see one example of combination formula. In how many ways the letters of the word triangle taking 4 letters at a time can be selected. The solution is the total letters in the word triangle is 8 and all are different. So we have to select 4 letters from 8 letters. According to the combination formula, the value of n is equal to 8 and the value of r is equal to 4. So the formula, that is C8 4, which is equal to according to the shortcut rules, first we have to write the multiplication form of factorial of this value r, that is 4, that is 1 into 2 into 3 into 4. So here we write 4. That's why we have to write the multiplication form of the factorial of 8 in descending order up to this 4th term, that is 8 into 7 into 6 into 5, which will give the value 70, which is our result. So there are 70 ways the letters of the word triangle taking 4 at a time can be selected.